Next one I want to talk about is the thymus gland. Now, the thymus gland is kind of an interesting one in that it's a gland that really works when you're younger and then it actually starts to die off, oddly enough. There are two hormones that are produced within the thymus gland. The first one is thymosin, and then the other one is thymopoietin. Thymosin um, is basically what's going to, and in fact, both thymosin and thymopoietin do pretty much the same thing. So when you hear those two, just realize the thymus has two hormones that do the same. What's going to happen is that it's going to help with the growth and maturation of T cells. And if you remember, T cells are a type of antibody that you're going to find within the lymphatic system. Although I don't think we've talked about the lymphatic system. I think that's next week. So remember T cells because they're going to be important. Anyway, so T cells are just a white cell that is going to fight diseases. And what's going to happen is that within the thymus, you're going to have these two hormones be released that are going to stimulate these T cells to be produced. And the interesting about it, once the T cells are mature, they'll actually just then go again into the lymph system and do their business. But what happens is that the body actually produces these in huge amounts when you're very young. But after a while, as you start to grow older and get through your teen years and mature, the thymus gland tissue starts to change and it becomes adipose tissue. So by the time, sorry, I'm a little tired. By the time you get into adulthood, that thymus, which used to be very active, is actually mostly fat. Mostly because it's not really necessary that it work throughout your whole life. Not only is it going to be dealing with T cell production, but it's also going to be working along with some of those secondary sex characteristics and growth. So, after a while, you don't need to grow anymore. You're good. You're done. And so the body just finds that it doesn't need to produce the hormone anymore because it's not really serving its purpose. Anyway, but the biggest part of the thymus gland is going to be the T cell production. All right. So that's the thymus. The next one we want to talk about is the pineal gland or pineal gland. Now, this one says it's a small, flattened, cone-shaped structure located posterior to the midbrain and connected to the roof of the first ventricle. Ooh, and so if you look on figure 12.2, and that is again on page, not that one, on page 261, the not with the parathyroids. Where did that go? Sorry, the pineal gland is actually up superior to the pituitary gland. And he's just a little guy in there, hanging out in the brain, doing his thing. This one to me is an interesting one just because of a movie that I saw when I was younger. My brother loved these movies called Mystery Science Theater, specifically 3000. Anyway, so what they would do is they'd play these old crappy movies, and then they would sit there and make fun of it the whole time. So you'd actually hear them making these comments during the movie. Super funny. These guys are really sarcastic, which happens from that kind of sense of humor. So I really loved them. And there was this old movie that they had done. I don't even remember what it's called, but it was really, really stupid. Anyway, it all had to do with this ring that was shaped like it was like a dinosaur claw. Anyway, so there was this monster that had this ring that would supposedly come and get your pineal gland and drain it of whatever's in there. Anyway, it's supposed to be like the fountain of youth, only it then turned the person psycho and made them into a monster. Anyway, so every time I hear the term pineal gland, it always reminds me of this really dumb movie that they were actually really funny when they were making comments in it. But it really interested me that even as recent as back in the 50s, we had such an inaccurate view of what was going on in the body. We, rather than thinking the pituitary gland was the one that kind of ruled all things, and hypothalamus ruling over all and directing the pituitary, we actually thought the pineal gland was the one that was in charge because it was higher up in the brain, and it was, obviously that meant it was more important. So, pineal gland is there, and he is important. Mainly, he only produces one hormone, but that hormone is really important, and that's melatonin. Now, melatonin, if you guys know about him at all, he is in charge of the circadian rhythm. The circadian rhythm is essentially the schedule in which your body functions. So, for instance, for me, my schedule is telling me I should be going to bed soon because I'm tired. And it's, and it's going to say when I need to get up, and it's going to regulate when's the best time to eat, when is the best time that your brain is going to function and be most aware and able to make the right decisions and absorb knowledge. All of those things are actually regulated by melatonin. And it's based on the levels or the amounts that the hormone is being released. Now, oddly enough, we don't know exactly how much is ruling what, and there's a lot of things that we don't know about the circadian rhythm. And in fact, when I lived in Philadelphia, I had this friend who was going to medical school at Penn State, which is a really good medical school. And his whole research was on the circadian rhythm, and so it was kind of interesting that it's something that he was getting his doctorate based on his research on the circadian rhythm. Anyway, so that's melatonin. You've probably heard of melatonin when you have like sleeping issues, so you can take it to produce drowsiness. The other interesting thing about it is that it inhibits the secretion of luteinizing hormone. So if we go back to luteinizing hormone, that's the one that stimulates ovulation and production of estrogen and progesterone, or testosterone. So that means that during ovulation, you probably produce less melanin or melatonin in order to have that hormone work the way it needs to for reproduction and ovulation. Kind of interesting. Let's see. Yeah. So that's the pineal gland. The last one that we're going to talk about is is not really a specific gland, but rather the fact that these glands are not the only places that hormones are being produced. And so we're going to talk a little bit about prostaglandins, and these are a group of local hormones made by most body tissues, and they and it's saying here that their names come from the fact that they were first discovered in male prostate glands. Doesn't that sound delightful? Oh yeah. Anyway, so basically what they're saying is that while these nine glands produce very specific hormones that are absolutely necessary for metabolic processes and for our body to function the way it needs to function, there are still hormones that are produced elsewhere, but the difference is that within the endocrine system, those glands are very specifically localized, and it's only those glands that produce that type of hormone. Whereas there are other hormones that are being produced, but they're produced all over the place and affect all over. So, basically, some of the characteristics of these prostaglandins is that they're produced, acted upon, and are rapidly inactivated in or close to their sites of origin. So, essentially, what they're saying is that these ones, even that they essentially just the body's going to absorb it quickly. It just is going to affect the area in which it's around because it's not going to flow all over. But when you think about the pituitary gland, for instance, it's again located by the hypothalamus, so it's by the brain, and yet it's affecting the ovaries for egg production and getting an ovulation. So that's a lot of distance between where the gland or where the hormone's being produced and where the target cells are located. Prostaglandins are not that way. They're just basically going to stay around the same area, and they're not really circulated by the blood. They're just going to be in the interstitial fluid. Basically, some of these are going to affect some of the smooth muscle with blood vessel constriction, bronchial tubes, and intestinal constriction, all those kind of things. Others can dilate, or they're just a lot of different response. So those are, again, prostaglandins. They just work in the areas and they're produced pretty much everywhere. Alrighty. So, so I think that pretty much just covers the whole chapter on at least what I feel like we need to know with the endocrine system. Hopefully this wasn't too boring for you. I really hope so. And if not, sorry. If you have any questions or anything that you need to let me know about, feel free to email me. And I hope you guys have a great week. I will try and get the test to midterm to you pretty soon. Again, it was just a crazy week. Not only was my niece born, but we actually had someone pass away in my family. So it's been a little crazy. So I'll see what I can do about getting that midterm to you, and I hope you guys have a great week. Bye.